The Collaborative Robotics and Intelligent Systems Institute at Oregon State University launched about 2 years ago when the robotics program and the AI program joined forces. We have about 30 faculty and 200 graduate students in our programs, and one thing that we're the most proud of is that we are one of the handful of universities in the United States who offers PhDs in robotics.
I came here because of the collaborative nature of the Institute, as well as the ability to collaborate with different groups across the university, such as oceanography and the Honeybee Laboratory. Another unique aspect is the fact that our faculty really do have different capabilities across robotics and artificial intelligence within the Institute, and so we receive a lot of requests from external organizations.
As robots are introduced in more and more everyday human-populated spaces, I think that human-robot interaction is a critical thing to consider. We need robots to be clearly understandable by people around them. They should be able to express themselves, help people understand what they're about to do or what their intentions are. And for me in particular, I'm excited about using sort of traditional capabilities of robots. Robots are tireless, they're repeatable, they're programmable, they're scalable, to put them in more everyday places where they can help people to live better lives, be happier, practice better habits.
Deploying 250 robots in the real world is really difficult. You need lots of people. As people know who work with robots, there's always problems. So what we do is we work with simulation first, and then we're taking the things we develop in simulation, which is never actually representative of the real world, and putting that on the indoor hardware platform of the 100 robots and 50 aerial vehicles to test that in a semi-real environment. And then the plan is to be able to gradually move from something that is very controlled to less controlled to an actual real-world environment for the swarm.
One of the things that we're working on is some research funded by the National Institutes of Health, looking at how we can use robots in response to highly infectious diseases. So this came out of the Ebola outbreak in West Africa a few years ago. And the question we came in with is, can we have robots help in a disease outbreak? Because you want to have the human healthcare workers a little more removed from the disease. If you can put the robot between you and the infectious disease, you can make people safer, maybe you can be more effective. That's a great application of robots because it's not taking people's jobs away, but it's making them safer, it's making them more effective at their jobs. I think the flip side of that, though, is it's very easy to get tied up in having robots to do a thing without really thinking hard, are robots the right answer to that thing? So one of the things that we've been doing is talking to Doctors Without Borders in Brussels, who run the Ebola response in West Africa, and trying to figure out if robots are the right intervention here, or if it's some other AI technology, or just better scheduling of human time, or what the right intervention is to get to the goal, which is less risk for the healthcare workers and better health outcomes for the patients.
So my laboratory has been focused on leg locomotion from the start, and we began with biomechanics studies, trying to understand how animals walk and run. Turning that understanding into a math model, and turning that math model, like a spring mass model, like a pogo stick, into a robot. And that robot was Atreus. Atreus was built to be that math model as closely as possible. Atreus was the first robot ever to reproduce the dynamics of the human walking gait. And we've leveraged that science result into new robots like Cassie, which are a lot more useful for being able to stand and steer and get around in the world reliably. We've spun out a company, Agility Robotics, with a robot that has arms and perception, start to do useful things like delivering packages to your doorstep.
Something that drew me here was the collaborative space that they have here. So all of the labs are shared in one huge space where all the labs are right next to each other, and that allows for a lot of seeing what other labs do and possibly collaborating with them.
So I really liked the diversity of the projects here and relative newness of each of the labs. So I was kind of aware that when I came here, I had a good chance of either leading a project or being high up on a project. I wasn't going to be put in a corner for a couple years while they sorted out whether I was good or not. But yeah, I like the diversity. There's a lot going on here and it's very exciting.
So the main vision is that robots and AI can't live in a lab. We started with saying we need to take it into the real world, but even that's not enough. We need to change the ecosystem, how they operate. What that means is robots are not just technical, but the social, economic, ethical, and legal implications of robots in the real world have to be studied. So we really focus on the entire ecosystem of how you build a robot, how do you put a robot in somebody's home, how does it work in a street, what does that mean for society, what does that mean for the future. Those are all the dimensions that we explore here at the Institute.